three spots. It gave three spots. While compound A gave what? Only one spot. What does that mean?
But
That compound A is a pure compound. Is a pure compound. Why? Because we have only one spot. Because we have only one spot. Okay? So if we have one spot, and it's very important, it's very important. If we have, we have a note here, note that if we have one spot, so it's a pure compound. A pure compound. If we have one spot, it's a pure compound. Right. What will happen if we have more than one spot? More than one spot. So it's a mixture, or we can call it impure compound. Impure compound. Okay? So, if we have one spot, so the compound is a pure compound. If we have more than one spot, it's an impure compound. Right. We have an example here. We can put a drop of milk into the filter paper by making chromatography. If we know that milk consists of two components. It consists of water and fats. Water and fats. So milk should give or must give two spots only. One for water and one spot for water, and the other spot is for fats. Okay? Fine. What will happen if the milk gave 3 or 4 spots? This means that this milk contains impurities.
beauty.
And these impurities give more and more spots. If you have a cocktail juice, for example, if you have a cocktail juice, and the company like Al Mara'i, Nadik, and so on, tells you that this cocktail consists of orange, apple, strawberry, and so on. They say that it consists of 4 components. For example, orange, strawberry, banana, and apple. For example, you can make paper chromatography to ensure that this cocktail juice contains 4 components. If it gives 4 spots, so they are right. خلاص? And what will happen if it gave only 2 or 3 spots? So it contains only 3 types of fruits. Okay? Type. The last part of the steps of chromatography, after separating the pigment or the colored compound into spots, we start to calculate, or at first we identify the type of the compounds inside this mixture. We identify the type and the amount. We can identify the type of the amount of this compound inside the mixture. Type. We can identify the type and the amount of the compounds inside this mixture by number 6, calculate something called RF. We calculate something called RF. Type. What's RF? RF equals, here we have we want to calculate RF. RF equals the distance from the baseline to the center of the spot. Look with me in page 13, figure 164. Figure 164. Okay? Figure 164. خلاص؟ Is it okay? Yes. We will calculate the distance. We will measure the distance from the baseline to the center of the spot. Like the spot A, for example. What is the distance from the baseline to the center of the spot A? It's 4 centimeters. So it's 4 centimeters. So we will measure the distance. يبقى RF equals the distance from baseline to the center of the spot divided by the distance of the solvent front. The distance from the distance of the solvent front. What is the solvent front? The solvent front is the distance from the baseline until the highest point that the solvent will reach. This is called the solvent front. Again, because this definition is not in your box. So the solvent front is the distance from the baseline until the highest point that the solvent will reach. What is the distance of the solvent front?
Until the highest point, okay?
I can't hear you well.
Distance from the baseline until the highest point that
the solvent will reach. The distance from the baseline until to the highest point that the solvent will reach. This is called the solvent front. It equals what in the base? In the figure, it equals what?
6 centimeters.
It equals what? It equals 6 centimeters. 6 centimeters. So the RF for this compound or this mixture equals 4, which is the distance from the baseline to the center of the spot, over 6, and it equals 0.067. خلاص؟ طيب. So we have calculated the RF. Every compound has its definite RF. Again, how can we identify the compounds in a mixture? Every compound has its definite RF. So, for example, ethanol. Ethanol has a definite RF. It has a definite RF. Methanol, carboxylic acids, and so on. All compounds have a definite RF. So we can identify the type of the compound by knowing its RF. خلاص؟ طيب. For the spot B, for the compound B, how can you calculate the RF of the compound? RF here equals 1.5 over